So welcome back from spring break, everyone. I'm really sad that I can't be there with you today, but this should be a good exercise today nonetheless. If you can remember back to over 2 weeks ago where we ended in our class, we played around with Python and Discovery. And remember, the goal was to we called it building satellites, but it was just really the bare bones build up of simple blocks and plates. And if you remember, we did something like this. We recorded these routines by using the script window, and I basically saved this thing that we ended up in class with. And if you remember, if you hit the play button on anything that you recorded when you generate, you're able to run that back. And we had varied success on this. Here's the basic building block of a satellite. We'll probably pick up more on this, or at least I hope to, maybe later. But right now, what I'm going to do is I'm just going to give you a satellite to work on. We're not doing this today. I just want to provide a little context. When I go to open later on, maybe on Friday, you guys will see this completed satellite module, which of course is a little bit closer to reality. You can see the thrusters on the side. You've got some aperture here. You've got the solar panels. We could just as easily build this up using, stacked scripting commands to ultimately get to this. But what we're going to focus on today is making an antenna that's going to be suitable for this satellite. So we're not going to mess with this anymore today. I just wanted to introduce this to you and show you where this is going, because our focus today is going to be in electronics desktop. Now, we didn't spend a lot of time on this last time in class, but here I am in electronics desktop. We talked about this Quadrafiler antenna type very briefly, but here you can see it's really just a very tiny object that's on the satellite. So what we'll do is we'll take an approach where we design the antenna. We'll spend a little time to talk about this antenna. You guys have already seen, I believe, a dipole antenna that we did at the end of last semester. Well, now it's just a different type of antenna that's got some different characteristics. But eventually we're going to put it on your satellite model, and that's going to be part of our communications link that we'll run later on. Okay, so I want you to go to electronics desktop. I'm in 2023 R1. It'd be great if you grab the same version, although it still will probably work if you did not. Instead of building up an HFSS design, I'm going to go straight to this automation tab. And if you remember this Show Hide Extensions button, I want you to click on that button and give it a second, and you'll see a docked window should be coming up on the right-hand side. And this is going to be our ACT extensions window. As soon as that loads, you'll see there's a couple of options in there for us to choose from. And what I'm going to go to is Launch Wizards. So hit the Launch Wizards button. And you should get the same 4 that I see here. I want you to click on the HFSS Antenna Toolkit button. And then that's going to open up another window. And if you remember, this was the template that we fill out for all these notional, I should say, textbook antennas. So it's going to be under Helix antenna. And we're going to do the Quadrafiler short. So if you click that button, the only thing that I want you to change is going to be the center frequency. Instead of 1 gigahertz, we're going to make it 1.620. And when you do that, don't forget to hit the synthesize button. And watch, these parameters are going to change as soon as I click on it. So the diameter of the helix, the spacing, all that is really dictated by the frequency that I want this thing to resonate at. I chose 1620 megahertz, which is the same as 1.62 gigahertz for a reason, because we are going to try to link this up to the Iridium satellite constellation. We talked about that a little bit in class. If we want this antenna to work based on that frequency, we have to design it to the right parametric size. So with that done, all of these parameters should be set, and I'm going to hit the Finish button. As soon as I do that, you'll notice over here on the left-hand side, my HFSS project is going to be automatically set up for us. So we'll go ahead and let that finish its course. Once that's done, you see this whole thing is populated. I can close out the ACT wizard window just by hitting that X button, and I can maximize that screen view. So here it is. You can go through and review it. I'm not going to do that. You guys all know how to do an antenna. We did a simple monopole antenna or a dipole antenna. I think we did both of them in a previous exercise. So we're just going to get right to it. I want you to run the simulation. So let's go over to the simulation tab. Since this was all done with Antenna Toolkit, I would expect to hit validate and have no issues. And when I do that, I'm now, once that's passed, I'm going to go ahead and say analyze all, and we'll let that run its course. And I'm not sure how long this is going to take, but I'm guessing probably just a few minutes, hopefully. So I'm going to pause my video while this solves and pick this right back up in a second. Okay, so on my machine, it took just a couple minutes. I'm guessing it's going to be the same for you. Remember, you can always check HPC options. I'm in the simulation tab. When I hit that button, if I click edit, it'll tell me how many cores I'm using. Since you're running this on the cluster, remember, you can always change the value of cores. You guys are going to be battling each other if you're running the simulation at the same time. But 8 cores, I think, is going to be okay for everybody. So go ahead and give that a shot. Hopefully you've already got the solution. As you would expect, a lot of the results have been, all of the results forms have all been filled in now. So let's just kind of click on a couple of these, and we'll kind of talk through some of the things that we see here. This is a gain pattern. We've already talked about that. If you might notice the name is a little bit different than what we're used to, but this is a 3D pattern, and this is indicating that it's a right-hand circular polarization plot. Now the other one here, if I double-click this one, it's for a left-hand circular polar plot. Now they look very similar, but depending on the way this is set up, it might have a stronger. It should most likely have a stronger intensity in one of those fields versus the other. You can get a good feel for that if you look at. Let's do this one. We'll click on the cut plane, and you can see the comparison for these fields are actually quite good. So I should say the comparison shows that they're about equal power for left-hand circular pole as well as right-hand circular pole. We'll talk about what gain means on Friday. I want to click on the return loss plot here, and what you'll notice here is that unlike the monopole, we actually have 3 different ports. We call them ports. Now, it's hard to see. In my example, they're all stacked up on top of each other. We never really talked about the performance of what this means, this trace, but you'll notice that it has a dip right here, right around the frequency that we were trying to design to, and that turns out to be a good thing. But the 4 individual stacked plots are corresponding to the excitations that are showing up right here. So 1, 2, 3, and 4. Now, if I go back to my model here, you can get a better feel for where these are. This is what we would refer to as a ground plane, okay, and that's where it gets its name. And then, of course, these are the elements themselves, and these are nothing more than helix, coils that are connected to each other at the top. And there's a really good reason for for doing this. I'll refer you to a second YouTube video that was done by an amateur antenna designer that does a really good explanation of how these things work, or at least how to build them, and a little bit of context on how they work. The feeds that I had mentioned, the excitations, if I just kind of click through here, you can always just rotate your design, and every time you click on an excitation, it'll highlight where it's been set. Very similar to the way Maxwell works when we define charges and things like that. So these 4 excitations are actually working together, and I want to show you something. If I right click on excitations and I go to edit sources here, you're going to see here that These all have the same magnitude. They all have 1 volt. But one thing that you'll notice is that the phase is staggered between the three. And that's important. So we haven't really talked about phase, but we're going to talk about that on Friday. And I'll give a little bit of context on what that means for this type of simulation. If you've ever heard of an array, an antenna array, you've probably heard of the term maybe phased array. And basically, by manipulating these magnitudes and phases, we can change the way that that pattern and the energy is being distributed. So it's a very important function for the quadrifiler antenna. So I'm going to leave it at that for today. This is all I really wanted you to accomplish. What I want you to do now is I want you to OK this. I want you to save this design. And actually, for the assignment, this is important. I want you to archive this design. So after you solved it, save it. And then I want you to go to File and remember Archive. And I want you to save it with whatever the default name is. And I want you to append your name. I'm going to put an underscore. Put your initials. I'm going to put my JPB. And then another underscore with today's date. So today is 04 April 10th, 2023. If you could do the same, then you'll save that. I'm going to put this up at the desktop so I can come back and get it. And now I'm going to get a message saying that the archive has been completed. Once you get this, make sure you see an AEDTZ. That means the archive is there, the results are there. I want you to send that to me over the Schoology assignment. So I expect you to upload this video wherever it is that, your project, wherever it is that you saved it, and send it to me. And that is all that is due for this assignment that's going to be due before class starts on Friday. So you have all class period today to get this very simple assignment done. I expect there to be no issues, and then we're going to have a good discussion on it on Friday. Thanks.